So let's take a look at another example of using this cross method to factorise quadratics. Let's say I had 15x squared, subtract 40x, and subtract 15. Now, as you can see here, our a value, so our pronumer or coefficient of x squared, is not equal to 1. It's equal to 15 here. But something I immediately notice between here, and hopefully you do too, is we've got a common factor. And each of these has a common factor of 5. So whenever we're factorising, we should really look for common factors and remove them as our very first step. So let's do that here. So if I remove my common factor of 5, 15x squared divided by 5 will be 3x squared. Negative 40x divided by 5 will be a negative 8x. And then negative 15 divided by 5 will be negative 3. So now what I've got here is I've got a quadratic inside this brackets that I'm going to factorise. But unfortunately, our a value is still not equal to 1. So our sum and product sort of strategy isn't going to be helpful to us here. So one method that we could look at instead is our cross method. So let's go with that. And what we're going to do is we're going to create that x column that I talked about. And we're looking for two numbers that multiply together to equal our a value. So our coefficient of x squared, which in this one is two numbers that multiply together to equal 3. Now in this case here, there's only one combination that will work, and that is 1 and 3. So then what we do is we look for two numbers that will multiply together to equal negative 3. Now one of these are going to have to be positive and one of them has to be negative. Now factors of negative 3 are going to be 1 and 3 again. So in this case, I'm going to make it a, let's do a positive 1 and a negative 3. So 1 times negative 3 will be negative 3. Let's have a look there and use this as my starting point. And what I do from here is I now cross multiply. So I go 1 multiplied by negative 3 will be negative 3, and 3 multiplied by 1 will equal 3. And now I add these two together, because if I add these two together and they equal the coefficient of my x, that means I've found the right combination. So 3 add negative 3 will be 0. And in this case, what I realise is 0 doesn't equal my middle term. So that means I haven't actually found the right combination, or I haven't got this combination in the correct order. So there's two things I can do. I can either change the different factors that I've got here, or change the sign of my factors in the second one. That could work. Or I could change the order that I've written them here. And that's where I'd always start personally. So in this case, I'm going to leave the order of the x column the same. So let's leave the x column as 1 and 3. But this time let's write negative 3 and positive 1 this way. And cross multiply and see how this one works. So when I cross multiply here, 1 times 1 will equal 1. 3 times negative 3 will equal negative 9. And when I add these two together, negative 9 add 1 will be negative 8. And negative 8 is the number that I'm looking for my coefficient of x. So what that means now is I've found the combination that will work here. And what I do with this is I bracket the top line and I bracket the second line, because these are my two linear factors. So when I do that, the first linear factor that I've got will be, so I've got to keep my highest common factor of 5 here. My first linear factor I've got is 1x, because it's in my x column, so 1x, which is just x, and then subtract 3. And my second linear factor that I've got here is 3x and plus 1. So what I'm proposing here is when I factorise this, it'll equal to 5 open up a bracket with my first linear factor of x subtract 3, then my second linear factor of 3x plus 1, and these linear factors are in brackets. But the advantage of all these is we can just check to make sure that we've got this right. So let's check this. Now, when I go to multiply this, I like to use my FOIL first and multiply these brackets out. So this will be 5. Our first terms, so x times 3x will be 3x squared. My outers, my x times my 1, will be plus 1x, or just plus x. Then my inners, negative 3 times 3x will be negative 9x. And then negative 3 times my positive 1 will be subtract 3 on the end. Now let's collect the like terms. So just here, I've got like terms. So this will be 3x squared plus 1 take 9 will be negative 8x. And then subtract 3. And then finally I need to multiply this 5 out. So 5 times 3x squared will be 15x squared. 5 times negative 8 squared, negative 8x. So 5 times negative 8 will be negative 40x. And then 5 times negative 3 will be negative 15. So what we can see here is our expanded form matches our expanded form from the top. So we've factorised this into the linear factors correctly. Now what's important here is when we're factorising when our a is not equal to 0, it does become a little bit of trial and error. But this method is a way to gather your thoughts when we're going through this trial and error sort of process. And it's really important to understand that you can change the signs of your factors as long as they still multiply together to equal what they need to equal. But you can also change the position of them and they'll end up with different sums when we cross multiply. So it's about just working through until you find the solution. Keep in mind, the more you practice it, the quicker you can actually identify what combinations of numbers will work from the beginning.